Yes, that's right.
Okay, so I'll have to ask for a slide advance. Okay, so now for something completely different, I would say we're going to look at maps of the rover traverses. And let's move on to the next slide right away. The previous maps that we had of these traverses were extremely generalized. And this is because even the very best images that we had before LRO were completely unable to show rover tracks. It's simply impossible to see those rover tracks in those images. And also you can't see the very small features that would be imaged in the foreground of a surface image that would help you to locate the rover with pictures taken during the traverse. So the traverses were necessarily very generalized in those maps. Next slide, please. Obviously, we're familiar with pictures like this, beautiful NAC image of the area around the LEM, and there we do see tracks. But I really have to emphasize that as soon as you get away from this area, even the beautiful NAC images do not show tracks in most places. There are some areas where they do. For instance, between station 3 and station 4, you can see tracks, but in most areas you can't, however much you crank up the contrast or anything like that. Okay, next slide, please. And so we have to do this. We can use pictures that were taken during the drives. Jack took lots of pictures during the drives. Gene Cernan took a few pictures as well. And when you have these images, we look at a picture like this one, you can see features in the foreground here. And if you could find those in a NAC image, then you'd know where the rover was at that point. Let's look at an example. We'll go to the next image. Next slide, please. Here we go. So this is a picture taken during the approach to the LRV2 sampling location. It's on the light mantle, and Jack is just saying to Gene, can you get on the rim of that crater? And sure enough, there are very faintly visible there, just beyond that, that thing in the foreground, which is the camera on the front of the rover. Just beyond that, you can faintly see some craters. And he wants to get onto the rim and then scoop up the rover sample. But that is a very low contrast image, largely because it's looking down sun. Let's go to the next slide. So here, the contrast has been cranked up considerably. And also the image has been oriented so that it's going to be easier to compare it with an LRO NAC image. And it's also been somewhat rather crudely reprojected, just a perspective projection. It's obviously still got distortions because we're not taking out the relief distortions caused by local topography. But still, with this combination of things, you get an image that is a little bit easier to compare with a NAC image. So now all you've got to do is find that location somewhere in a NAC image. And if we go to the next slide, there we go. So there is that image, and a few features are noted. We could find others as well. There are probably 5 or 6 features that you could clearly identify to demonstrate that you've got the right location. And in, some features out in the far field as well that aren't shown here also help to locate that. So we know pretty much where the rover was when that picture was taken. And it's at the convergence of those lines on the right-hand side. Now let's go to the next slide. So if you do that for a variety of images, images as you're moving along, you can start to trace out where the traverse took the rover. There are still images that are not located like this. Some images are extremely bland, and some areas are blander than others and just don't have very many features that you can identify. So there are some images that are not located, but enough are that you can do a pretty good job of putting together new traverse maps. So let's go to the next slide again. And call this a sanity check. You take the NAC image of that area and really crank up the contrast. And sometimes you can just sort of convince yourself that you can see faint tracks, and I've tried to identify a few here. But there's a problem with this, and that is that these images throw up a large number of false positives. And even if you just look around here, you might be able to see some, especially right on the left-hand side of this image and pointing kind of north-south, completely wrong. But there are lines, even double lines, that look like they might be tracks, but they're not. So you, with hindsight, knowing where the rover was, you can sometimes find spots where the traverse should be, but it's very, very difficult to actually do that without having located the rover by using the other method. Let's move on to the next slide. Yeah, next slide, here we are. So I'm going to look at a few examples here. This is EVA1. EVA1 was a bit of a problem because on the way out from the LEM to station 1, Jack was holding an explosive charge for the active seismic experiment. And so he couldn't take pictures. He was holding it in front of him and he couldn't use his camera to take pictures. Gene Cernan did take a few pictures along the way, just here and there. But on the way out to station 1, very few pictures. And so that is still not well mapped. On the way back, the explosive charge had been set down at station 1, and Jack could take lots of pictures. And so we have a fairly well reconstructed path there. And actually some of those return images show the tracks, and there are a couple of places on that map where you can see that the inbound and outbound paths cross. So there you are going to see the outbound tracks, so that you get some information there. I just want to draw your attention to EP7, just below the white box in that map, because we're going to come back to that point and say something more about it later on. Let's go to the next slide, please. This is one of the inbound images, then the northbound image showing the southbound tracks. So you get several in a row that show those tracks, and you can map part of the outbound, southbound path that way. Okay, so now next slide, please. Move on to EVA2. I'm only showing the western part of it. With EVA2, some parts of this, the new map follows the old map very closely, like between station 3 and station 4. But in the outbound portion, the tracks are very widely divergent, several hundred meters away from where they're supposed to be. The pale white line is the old map from 1975. And the dark line is the new map, and they're several hundred meters apart in part of that image, sort of center right there. The LRV2 site was the one that we looked at for our location example, and it's about 300 meters away from where it was anticipated. And the LRV3 site is 400 meters or so away. Okay, let's move on to the next slide, please. This shows the approach to the scarp, and it's something that has never been adequately mapped before. The old map, which is those broad pale lines, shows the path driving right up to the scarp, straight up and over the top and off the other side, and then coming back up onto the slide and kind of up onto the scarp and along the top of the scarp and out. But the reality is quite different. The line coming in right up in the top right corner shows the rover driving towards hole in the wall, the gap in the scarp. And Gene is saying, I've got to go around a long depression. I don't know how I can get over there. Then he says, we can't get in there. I'm going to go over here. There's a depression blocking hole in the wall, which I show with dashed lines there. So he swerves to the left, round, and then a kind of S-shaped curve, and then into the scarp again, just south of hole in the wall and up it. If you look in my abstract, you can see the image that was taken just as they approached the scarp at that point. Up and over it, and then on the way back, they drive to the scarp and down off the scarp, and then to the northwest along the base of the scarp. And actually, as they do, they can actually see the tracks from the inbound part of the drive. So we have images that show those tracks, and they're certainly properly represented there. Okay, let's move to the next slide, please. This is EVA3, and again, in many areas, this follows fairly accurately the old map. But there's one area between Station 8 and Station 9 on the right-hand side that is about 300 meters off the old map. Let's move to the next slide and see it in more detail. Here we are. The old path, the pale white line, broad white line, goes to the left of a dotted depression there, the east side of it, sorry, the right-hand side, the east of that dotted depression, and then turns to the west. But actually they drove up to the rim and then turned right to the west along the top of that depression and across it before coming down to the large crater in the lower left. So little details like that, but there are substantial changes in some areas to these maps. I should point out that all of the science stations were very accurately located because of the great panoramas that were taken at the sites anyway. So they're not in question. It's these paths between them that get to be improved. Next slide, please. Yeah, next slide, please. There we go. Map availability, I want to say something about this. The maps I've shown, which have the little quotes from the transcript on them, were drawn for a future publication. They will be in the Apollo Lunar Surface Journal as well, which is currently going through a major update. I don't know exactly when it will be available, but the maps will also be available. They're being used in dynamic mapping on the LROC featured sites website. Apollos 15 and 16 are already there, and Apollo 17 should be in time for the anniversary. And if you haven't seen this site, it's great. You choose your mission, you choose your EVA, and you get a timeline for the EVA, and you can move a slider along it, and the little rover icon moves along. It's tied to the transcript, so you can see a few lines of the transcript in the bottom there. It's tied to images. You can link to the images that were taken there. So in some ways, this is doing what Apollo in real time does. Apollo in real time does a lot more than this, including all the great videos. But what Apollo in real time doesn't have is these maps. So the two together work very well. And if I could go to the next slide, please, just to quickly pack up. In some places, the rover was driven around in a little loop and pictures were taken to make a rover panorama. The one at the top is Victory Crater on EVA2, and the one at the bottom is the EP7 site on EVA1 that I pointed at then. Let's just move to the next slide. If you have that panorama, yeah, the next slide, please. If you have that panorama, you can project it out. This is a stereographic projection of that panorama, and then you can locate the features on the LRO image and find that location. And if I could just go to the last slide, please. The one remaining thing that we're looking for here, which hasn't been done, is to find the Apollo 17 lunar module ascent stage, which crashed somewhere on South Massif. It should be visible in NAC images, but it hasn't been found. We have got Apollo 12, 14, and 15 impact sites, but not the Apollo 17 ascent stage impact. It's in there somewhere, and I hope that we will eventually find it. And if anyone has any suggestions, I'd be very eager to hear them. Okay, thank you very much.